Hello everyone, welcome back to the class real-time system. Today we are going to discuss about memory management. So it's nothing but, so we know that all the programs, whatever the code, whatever the important contents, so that will be stored into the memory. So that memory need to be managed. How it will be managed? Okay, so that is what we are going to discuss in this memory management. Since most of the control application softwares are static, okay, so whatever the softwares which is need to execute, so that must be a static. The dynamically the program will not be created. So that particular programs are stored into the bootstrap ROM. Okay, so that software is not a dynamically created or eliminated at the runtime. So the problem of the memory management is very simple. Okay, so the reducing the cost of the computer hardware and then processor and memory and many controlling applications which uses the program which are permanently resident in fast access memory. Okay, so the fast whatever the program which is required, that will be stored into the fast access memory. So in this left side you can see here the memory which is divided here, the memory which contains the bootstrap ROM, it is nothing but a high level memory, and operating system and device handler, user space and system workspace, and your system workspace is nothing but a low level memory. So in this, whatever the bootstrap ROM which is there, that is high level memory. So all the necessary programs are stored into this bootstrap memory, and operating system functionalities, that particular softwares are stored in the place of operating system, and device driver, device handling informations are stored into this particular field. And the user space, here you can see this the single user space which is given. So whatever the program which we need to store, that must be stored into the user space, and system workspace is nothing but a lowest memory. Okay, so the user space is treated as a one unit, and then software is linked and loaded as a single program into the user area. So the informations about the various tasks that can be conveyed to the operating system by means of creating a task statement. Okay, so how to creating a task ID, priority, start address, and then workspace. So based on that it will be generated. And you see earlier whatever we have talked in the diagram, so that is nothing but a non-partition memory. So it is nothing but a partition memory. So you can see the difference between the partition and non-partition memory. So in this partition memory, the user area is divided into the number of parts, number of segments it will be divided. In an earlier non-partition memory, single user area, the data need to be stored into the single user area as a single program. Okay, so the available memory is divided into the predefined segment, and then tasks are allocated individually into the various segments. So the load operations would normally be carried out using the command processor. The entries in the task descriptor that have to be made from the console using the memory examine and change the facilities, so which will be divided. The partition memory was widely used in the many of the real-time operating systems, and it was frequently extended to allow the several tasks to share the one partition. So the tasks were kept in the backing store and loaded into the appropriate position whenever it is required. So this is called demand loading. Whenever it is required, by demanding, the data content will be loaded into the main memory. So the task which timing was crucial was placed in the fast access memory, which is permanently will be there in the fast access memory. So other tasks were swapped between the fast memory and also a backing store. In that, the system which allows the dynamic memory allocations allow the task themselves to initiate the program segment transfer either by chaining or by an overlaying. So the chaining the task is divided into the several segments which run sequentially. So on the completions of one segment, the next segment is loaded from the memory into the area occupied by the previous segments. The any data required to be passed is held either on the disk or in the common area of the memory. So the task swapping, which involves one task which involves the another task. So here you can see this, the task chaining and task swapping, the diagram which is represented here, the task one which is pointing out to the next task. The next task is nothing but a point for task 5, and then task 5 which is pointing out to the next one, it is on 6, and then task 6 it is pointing to the next one is task 7. So once if it is completed, it is returning back to the task 6, again it is returning back to the task 1. So like this how the task 2, only the task 1 which is represented, and also a task 3 is represented. So the task 3, once if it is done, it is loading to the next task is 8. So once if it is completed, and it is returning to the task 3, and task 4 if it is completed, and it is returning back to the task 1. So like this how the task swapping which performs here. So there is a differentiation between the task chaining and overlaying is that in overlaying, a part of the task is a root task remains in memory, and the various segments are brought into the overlaying of area of the memory. In a multitasking system, there may be a several different overlay areas shared by the several tasks. So that figure which shows the two tasks, each task maintain the root segment and overlay area, and then various overlaying are loaded into and out of the overlaying area of the memory. Okay, so this is nothing but a task overlaying. So the task overlay is here. So the overlay 1, overlay 2, and it is overlapping the task 1 by 1 up to the task 15. So this is one of the task overlaying diagram. Okay, so these are the references. So like this how the task will be, the memory will be managed. So it is one of the resource. The resource will be managed and stored the data into the memory management. I hope this video is very helpful for you. We'll meet you in the next video. Thank you all.